So back to the problem. This was question 5 in worksheet 1. So here we've got y equals x e to the 3x. We took the derivative, 1 plus 3x e to the 3x, and we found where that was equal to 0, and we got the answer x is minus a third. Y is minus 0.123, substituting that back into the original function to give us the xy pair, which we've put down here. So we know the turning point is at this point. The next bit is to find the nature. And we find a nature by finding the second derivative, d2y by dx squared. And that's, I'm going to kind of gloss over this a bit, but essentially you take this thing here and you take the derivative of it. I'll write der there to indicate derivative. And when you take the derivative of that thing, you get 3 brackets 3x plus 2 close bracket e to the 3x. So that's the derivative of that term there. Now you do that using the product rule. You can see here we've got a u bit there and a v bit there, and you just apply the product rule, factorize a bit, and you get down to here. So what we now need to do is use this to find the nature of this turning point. Now you'll notice that the function has x's in it, so we're going to put that minus a third into there and into there instead of x, and that works out at 1.104 when you do the calculation. So that means that this is a positive value. So d2y by dx squared at x equals minus a third is positive. And from now on, I'm going to use plus VE to indicate positive. That's kind of conventional notation. So what does that mean? Well, in the last video, we established that a positive second derivative at a turning point means that this is a minimum turning point. So now I can rewrite this in summary. So I'm just going to copy this bit down. So copy that. And down here, paste it in. Oops, paste. Drag that down there. So the turning point is at, and it is minimum turning point. And that's our problem complete. So just to recap, we started off the original function, we found dy by dx for it, and then solved where it was equal to 0. That was the last video, or the last video we were tackling this problem rather than talking about second derivatives. That gives us x minus a third. We then find a y value by substituting back into the original function. So that gives us our turning point. We then take the derivative again to get second derivative, d2y by dx squared. Find out what that is, substitute the minus a third in, and we get a number out, and if it's positive, it means it's a minimum turning point. If this had turned out to be negative, it would have meant a maximum turning point. And then we can summarize it at the bottom of the answer, and that's the problem done. So at this stage, we can now go back here to our graph. You can actually see here, this is the problem. Just go down, we can see the working. So I would rework this lot. They've used the dash notation. I would use the d2y by dx squared type notation. But you should be able to follow it. You can see minimum turning point at minus third minus 0.123. So what comes out of it. And then if we work down a bit, we get to worksheet 1. And then go down to question 10 onwards. Would be worth trying. Now you'll notice that, so question 10, oops, there we go. That's very, very similar to the one we just did. So you should try that one. And then down here, question 11 is an optimization problem. Now, what I would suggest here is, well, question 10 in some respects is more like the one we've just done, so that might be worth trying that. And then question 11, if you do this at the end, this is an optimization problem, but it does require a bit of information, and that information is the volume of a cylinder. Now, volume of a cylinder is pi r squared h. And you need to know the basic volume rules. So this is probably something you might have learned back at maybe National 5 level or even National 4 level, or possibly sometime in the past doing Craft 1, I think has volumes in it. If you've done that unit, the volume of a cylinder is pi r squared h, a cylinder. The ones we don't need here, volume of a cone is 1/3 pi r squared h, right, cone there. And volume of a sphere is 4/3 pi r cubed, sphere. Now, if you don't know these at this stage, you need to go away and learn them, practice them, maybe Google calculate volume of a cone or something like that, and just do some examples, because these are important in lots of engineering applications. So volume of a cylinder, that's the one we need for this question, is that one. Have a go at it. If you can't do it, after a bit of time, chat to your friends. If you still can't do it, look at the worked answers and the notes provided, and then give me a call if you're stuck, or give me a shout if you're stuck. Okay, so hopefully that's the end of product rule. Once you've done all those, we'll look at quotient rule next.